Imagine being able to travel across the universe in the blink of an eye. Sounds like science fiction, right? Well, the concept of wormholes suggests it might not be. This intriguing idea of wormholes has been a tantalizing topic of discussion for years. This concept, rooted in the complex world of theoretical physics, proposes a shortcut through the fabric of space-time, a passage that could theoretically allow us to traverse vast cosmic distances almost instantaneously. This isn't just a topic that's captivated physicists and mathematicians. It's also seized the imagination of science fiction writers and fans, creating a fascinating intersection between theoretical science and imaginative storytelling. From the pages of sci-fi novels to the rigorous equations of theoretical physics, the possibilities of wormhole travel have been explored, examined, and extrapolated. But what do we really know about these cosmic shortcuts? So, what exactly is a wormhole, and how could it potentially function? Let's dive into the intriguing world of wormholes and see what we can uncover. In simple terms, a wormhole is like a shortcut through space and time. To really grasp this idea, let's use an analogy. Imagine you're on one side of a vast mountain and your destination is on the other side. You could hike over the mountain, which would take quite some time, or you could take a tunnel through the mountain, getting you to the other side much quicker. That tunnel, in essence, is what a wormhole is in the cosmos. A shortcut through the fabric of space and time. Now, wormholes are not physical tunnels with walls and lights like the one in our mountain analogy. They are theoretical passages through space-time, the four-dimensional fabric of the universe that Einstein described in his theory of general relativity. Space-time can be visualized as a two-dimensional sheet that's curved by massive objects like stars and planets. A wormhole, then, would be like a tunnel connecting two different points on this sheet, creating a shortcut for what would otherwise be a long journey across the universe. Think of space-time as a piece of paper. If you're trying to get from one corner to the other, you could go across the surface, which would take quite a while. But if you could fold the paper so the corners meet, your journey would be instant. This is the basic idea behind wormholes. However, it's important to note that wormholes are purely theoretical at this point. They are a solution to the equations of general relativity that describe space-time, but we have no empirical evidence that they actually exist. They remain a fascinating concept, a tantalizing possibility that has fired up our imaginations and inspired countless science fiction stories. So we've established what a wormhole is in theory, a potential shortcut through space and time. But how would a wormhole actually work? The workings of wormholes are purely speculative and based on Einstein's theory of general relativity. To understand wormholes, we first need to grasp the basics of Einstein's general theory of relativity. It's a theory that describes gravity not as a force, as Sir Isaac Newton did, but as a consequence of the curvature of space-time caused by mass and energy. Imagine a trampoline with a heavy ball in the middle. The ball creates a dip or a curve, and that's similar to how mass or energy distorts space-time. Now, let's take this concept a step further. Picture that same trampoline, but instead of just one ball, we have two. The indentations they create connect through the fabric of the trampoline. In the cosmos, this could be likened to two massive bodies, like stars or galaxies, creating a tunnel through space-time. That's essentially the concept of a wormhole. But how does this tunnel come to be? To understand this, we need to delve into the concept of bending space-time. Imagine you're on a piece of paper and you want to get from one side to the other. Instead of traversing the entire length, you could simply fold the paper so that the two sides touch. This is a crude analogy of how bending space-time could theoretically create a wormhole. By bending space-time, two distant points could be brought together, creating a shortcut through the universe. Now, it's important to remember that all of this is highly speculative. The existence of wormholes is not supported by empirical evidence, but rather by mathematical models and theories. We don't have any proof that they exist, nor do we have a way to create or manipulate them. Yet, these theories provide a fascinating starting point for discussions about the nature of our universe and the potential for interstellar travel. Now that we've got a basic understanding of what wormholes are and how they might work, let's discuss their potential. The potential of wormholes is truly mind-boggling, with implications that could change our understanding of the universe. Let's start with space travel. If wormholes exist and we could harness their power, we could potentially travel vast distances across the cosmos in the blink of an eye. Imagine it as a cosmic shortcut, a path that bends space-time itself to connect two distant points in our universe. This could mean that interstellar travel, the stuff of science fiction, might become a reality. We could potentially visit other star systems, galaxies, maybe even the farthest reaches of the observable universe. Now let's take it a step further and delve into the realm of time travel. Depending on how a wormhole is structured, it could potentially not only link 2 points in space, but 2 points in time as well. This is a concept that has been explored extensively in science fiction, but it's also a possibility that has been seriously considered by physicists. If this were possible, we could potentially travel back and forth in time, much like we might travel from one city to another. And finally, let's talk about the most speculative yet intriguing possibility of all: multidimensional travel. Some theories suggest that our universe may be one of many, part of a multiverse. If this is the case, then wormholes might provide a passage between these different universes, allowing for travel between entirely separate realities. It's important to remember, however, that these are all theoretical possibilities. While the mathematics of Einstein's general relativity allows for the existence of wormholes, we have yet to find any empirical evidence to support their existence. There are also significant challenges and unknowns when it comes to the practicalities of traveling through a wormhole. So while wormholes remain in the realm of theory for now, they offer a fascinating glimpse into the potential future of cosmic exploration. Who knows? Maybe one day we'll find a way to make science fiction a reality.